Right, so it is about absolute value inequalities, quite tricky little things and take quite a lot of working through. So I'm just going to illustrate with an example, and hopefully that will give a good method of how to do them. So let's go and share the screen, and we'll go straight into absolute value inequalities. Okay, well, now this, you've spotted it, this first one isn't actually an absolute value inequality, it's just an inequality. But I want to use this as an example for solving quadratics, because when we come to do absolute value inequalities, we just need to kind of watch out for a couple of things from that we'll learn from this case. So, so let's have a go at this first of all. Okay, so find the possible values of k which satisfy the inequality 3k squared minus 2k minus 1 is less than 0. Right, I've actually graphed this over here, so this kind of gives us a guide. Obviously, if you're doing an exam, you're not going to be able to do this, but for the purpose of this video, it's quite useful to be able to see it there. So first of all, if we're going to solve this, this doesn't easily factorize, so I'm just going to rewrite this. I've divided right through by 3. So I can just restate the inequality like this. Now, I think the best thing to do with this is to actually do a completion of the square. So if we just do that process, I'm assuming you understand that and you know how that works. So that's going to give us k minus 1/3 squared is less than 4/9. Now we have to be a little bit careful here, because when we take it depends whether we take the positive square root or the negative square root. So if we take the positive square root, then we're going to get k minus 1/3 is less than or equal to positive 2/3, and that's going to give us a solution of k is less than 1. If we take the negative square root of this, then we've got to change the sign. So remember to do that. So that's going to give rise to this solution k is greater than minus 1/3. So that's it. So if we compare that to what we've got here, well, we can see that's just about right, really. But k is greater than minus 1/3. That's this point here, and less than minus 1. So that's the region in which the value of k has to be in order for this inequality in the question to be less than 0. Okay, so so the main thing I really wanted to kind of bring out there was the fact that we have to be this careful when we take the square roots as to what we do with the sign of the inequality. Okay, so let's wind down, and we'll go to this one. Now this is quite a bit harder. I mean, obviously it's absolute value inequality, but also it's got two absolute values in it. So that makes it sort of fairly complicated, and I mean, you can get these as complicated as you like, but in terms of exam questions, this is probably about as difficult as you're going to get. So again, I have graphed the function of absolute value of x squared minus 3x minus 4 minus the absolute value of x plus 3 over here on the right. You can see it's a kind of weird kind of function, but it shows clearly where it's actually less than 0. So again, in an exam you wouldn't be able to do that, but for the purposes of this video, it helps. So so what I've done here, and this is just part of the method really, is I draw the number line and mark on it the critical points, which then define the critical regions. Now, the critical regions are defined really by when these factors change sign. Now, factorize the first one, just to make it a bit more visible. So, so this x minus 4, x plus 1. Now, this is going to be, it's going to be positive when x is less than 1. Because both terms will be negative. It's going to be positive when x is greater than 4, because both terms will be positive. But in between, it's going to be negative. So this is a quadratic, isn't it? It's going to be, it's basically the bowl shape, you know, of quadratic functions. Now, the second one, x plus 3, is just going to be, this is just linear. So obviously, when x is less than -3, it's going to be negative, and otherwise it's going to be positive. So this gives me this little analysis here. I've got these 4 different regions that I need to consider, and it shows me the sign of each of these in turn. Now, the behavior of this first or each of these absolute values depends on which region it is, because if, for instance, we're in region 1 here, then this x plus 3 modular absolute value of really you treat as you can take away the absolute value signs and just substitute a minus sign. So so let's just kind of work through that. So to say we've got to do each region in turn. So let's just do region 1 to start with. So what our inequality now becomes in this region is x squared minus 3x minus 4, and then well, it's kind of negative x plus 3, isn't it? Double negative is less than 0. And if I rewrite, that's going to give me x squared minus 2x minus 1 is less than 0. Okay. So as in the above example, then what I'm going to do to resolve that, because that doesn't easily factorize. So let's have a look at this. X squared minus 1 minus 2 is less than 0. That's what that gives us. And therefore, we can take the 2 cases out of this. One is on the positive square root, it's going to be x is less than 1 plus root 2. And for the negative square root, we're going to have x is greater than, the change of sign, 1 minus root 2. Now, the thing about these 2 solutions basically is that neither of them fall in this region. So we are only interested at the solutions that we come up with here. We only pertain to this particular region. So essentially, we kind of discard these 2 because these are numbers which fall further up the number line. Okay, so that is region 1. Let's have a look at region 2 now and see what that gives us. Okay, so now we're going to rewrite this as x squared minus 3x. This is still positive, so we're just taking the absolute value signs away, and we've got positive out front, which we don't write, of course. And then, but in this case, we've got absolute value of x plus 3 is positive, so it's minus the positive of, should be x plus 3, okay, is less than 0. Okay. Okay, so so that's going to basically give us If we rearrange, that's going to be x squared minus 4x minus 7 is less than 0. And then again, completing the square, we've got x minus 2 squared minus 11 is less than 0. And that's going to give rise to two solutions. One, which is x is less than 2 plus positive root 11. And the other one being x is greater than 2 minus root 11. Okay, so so this value here, this first one, this falls outside our region, but this one is inside our region. 2 minus root 11. This is about negative 1.3. So it's basically going to be about well, about here, isn't it? Something like that. So maybe we'll do that in black. Yeah. Okay. So so that is what we get, and so greater. It's got to be greater than that. So let's just mark it on here as with the black line. So it's that bit. And then I said we're only interested in region 2. We're only solving for region 2 at this point. So so it's just that area here. Let's look at region 3 now. Okay, so region 3. Now, if we put the signs on our absolute values, we're looking at this inequality, and that's going to give rise to well, let's just assume that we can work that through. It's going to come through to x squared minus 2x minus 1 is greater than 0. This is a negative x squared here, so I've changed the sign, so that's why we're looking at greater than 0. Okay, so again, completing the square, x minus 1 squared minus 2 is going to be greater than 0. And that's going to give rise to solutions x is greater than 1 plus root 2. And then, of course, with the negative roots, then we're looking at changing the sign to x is less than 1 minus root 2. Now then, so this first value here, it's around about positive 1 plus root 2. It's going to be about 2.4, and this is going to be around about negative 0.4 here. Now, 2.4 is outside our region, but negative 0.4 is in our region. It's going to be about here. So so what we're saying, stick to black, is around about here. It's going to be this region here. Okay, so so there we've got one region, and we know from our graph over here we're actually going for another region, aren't we? So let's just carry on with it, and we'll finally look at region 4. Hopefully this is going to give us two values. So region 4, right? Okay, let's just go rewind on this, because obviously 2.4 is in our region. In actual fact, it's around about here. So in fact, it's all those values there. Okay. Right. That's better. Okay, so we're doing okay so far. So region 4, let's have a look at this. So now we'll rewrite our inequality. Less than 0, because these are both positive now. And yeah, so this simplifying this, going right through the process. I won't do all the algebra here. That's going to give us this inequality, and then completing the square again. That's going to go to x minus 2 squared minus 11 is less than 0, and that's going to give us solutions x is less than minus 2 plus root 11, and x is greater than 2 minus root 11. X is less than 2 plus root 11, and x is greater than 2 minus root 11. Well, this second one is it's a negative number. It's not in region 4. But this one here, root 11, what's this? Is something like this 2 plus root 11 is something like 5.3 or something like that. So this is in region 4. Where would it be? About there. Okay. So we've got all our solutions there then, basically. We can say, so a little bit of color coding. This is a solution here. We've got 2 solutions in region 3. We've got 1 solution in region 2. We've got no solutions in region 1. So basically, we just have to kind of write this out in the appropriate form. X is less than, and so on. And we can see that actually it corresponds quite nicely to our graph. So there we go. So this is what we have to do with these things, is basically you have to break it up into regions and consider each region in turn. And then when you find the solution, it only applies to that region. And remember, when we're doing quadratics, is we have to look at we have to make sure that we get the sign right on our inequality on the final sign. So hopefully that has been useful. So I'll see you in the next video.